I'm Éric DESAULNIERS, founder, CEO, director of Nouveau Monde Graphite.
So great to see you today. My first question, I think a lot of people are wondering, is what's so important about graphite?
Yeah, graphite is used in a lot of different applications. So there's a big legacy traditional markets. It goes in bricks in the steelmaking industry. It goes in pencils. My kids still use graphite in their pencils. It goes in lubricants. It goes It goes also in the foil for iPhone, refractory bricks. And now it goes in the lithium-ion batteries. So it's a very big growing market, and that's something that makes us very excited.
Now, your mine would be one of the first in North America. Is that true?
There's currently only one mine. There's one mine in North America. It's operated by Imerys Graphite and Carbon. So it's a conglomerate, a French company named Imerys, is NK, the symbol on the CAC 40. So they operate since 1989. So Imerys is the only producer. There's few startups that are starting projects, and we are one of them. So there's only 2 advanced projects. So now we have a feasibility study, and we just started an operation two months ago. So we're producing 2,000 tons of graphite in the next 24 months, and it's the first operation since Imerys of graphite in North America.
Now, why is North America important? Why not just get it from, Australia and China and other places?
Yeah. So you need first of all to have a very good graphite that is highly metamorphosed and that has the right quality for the application. We have this. Imerys proved that up in the last 30 years. So you need the right metamorphism, the right geology. So if you don't have the right metamorphism, the carbon would be coal, for instance. You have location, you have coal, and when the metamorphism gets higher, it becomes graphite, and if the metamorphism gets even higher, it becomes diamond. So here in North America, where we are in Quebec province, we have the right geology. First of all, you need also a lot of water. So you need water. In Australia, they don't have enough water for the flotation cells. We need about 30 meter cube of water per hour.
Oh.
So it's a lot of water for the flotation cells. We are recycling all that water, but when we do the drying at the end, it's evaporating. So you need to have a lot of water. It's something. Electricity is very important in the cost structure. You need skilled labor. And then also you need to have the market. So we have a market here in North America that are buying graphite. So the other producer on the planet is China. It's about 2/3 of the market, 67% of the market. India, 15% of the market. Those 2 countries mostly use the graphite for their internal usage. They export a little bit, but China now put export tax on their graphite because they want to force the graphite to be transformed the most possible in value-added product, including batteries, and also Brazil, and Canada is the fourth country in terms of production, with only 2% of the market, 20,000 ton on a 1 million ton a year market.
Now, when people talk about batteries, they usually talk about the sexy stuff, the cobalt, the lithium. But I was surprised to see that there's a lot of graphite. Why is graphite used in a battery?
Actually, so there's the cathode in the anode. So you need the graphite to host the lithium ion in the battery. So it's a very important part of the battery. You cannot remove the graphite in a lithium ion battery. So, the cathode could be lithium, NMC would be nickel, manganese, cobalt. NCA, like Tesla, will be nickel, cobalt, aluminum. Mm-hmm. There's LFP, lithium iron phosphate. So that's the cathode chemistry. Okay. But then the anode is always graphite. It's graphite, natural or artificial. And now they start to add a little bit of silicon to increase the capacity, but they can put maximum 3 to 5%. So that's the anode part of it. So roughly 14% of the battery is graphite.
Oh, wow.
So that's why Elon Musk said a few years ago, it should be called a nickel graphite battery, not a lithium ion battery. But
Interesting.
That's just Elon saying that.
Just Elon. It's just Elon saying that. So a lot of people are talking about the next stages of EV batteries, and they're talking about things like graphene and supercapacitors. How does graphite, graphite sounds like graphene. How does graphite fit into that?
Yeah, so graphite, actually, it's like millions of graphene layer bunched together with weak bonds, van der Waals bonds. So that's why a pencil can write, it's because actually you have all those weak bonds that are releasing all the graphene layers on a sheet of paper. So a graphene layer, it's like an atomic scale, 1 atom thick. It's look, recently they've made a lot of, actually that's how they made the discovery of graphene. It's using a pencil and doing the scotch tape until they were able to isolate a single layer. So graphene is a very interesting product. There's a lot of R&D around the globe for graphene. There's one very interesting application in the lithium-ion battery. It's not to replace the active material in the anode. It's really as a conductive additive in the cathode, because in the cathode material you need to add a conductive additive. Currently, it's carbon black. They add a very specific carbon black that is conductive to make sure that the conductivity is right in the anode, in the cathode material. Okay. And graphene could potentially replace this conductive additive, but it's not the right product for replacing the active material in the anode. Actually, spherical graphite. It's you take a flake and then you micronize and you make a small ball. That's what they use in the batteries. It's spherical graphite.
Interesting. So this really is a much more important mineral than we kind of think about, even though we're thinking about what we think are like lithium and so forth. This makes up a huge part of the battery. Yeah,
it is very important in the battery. So I would say graphite, it's a very important stuff for a long time in the battery.
Now, how did you find out that your mine location had a good supply of graphite in it?
Yeah, so that's my expertise. I'm a geophysicist by training. So when I started this company in 2012, we went public 2013. It was really an exploration idea. We all knew in the area, I'm living close to the mine of Imerys actually, so we knew that the mine there was more behind than in front, like it was near depletion. So, and we knew also that the geophysical technique that I was expert in, airborne geophysics, time domain EM. So we are measuring the conductivity of the ground with an EM loop. Graphite is a direct detection. There's not so much commodity that you can directly detect with geophysics. Graphite is one of them. So we covered over 10,000 square kilometers, so roughly 80% of the Connecticut state. And so a very big area to finally discover in this location a very large conductive anomaly, 14 kilometers. So very big conductive anomaly. We started to drill in 2015. We invested over $25 million in drilling, proving up the resource. So now it's, we have rules in mining. I cannot tell you, I have 96 million ton of ore until it is drilled at certain distance every hole, and it's stemmed by an independent engineer. And that's what we've done. We've made all the steps, and now we have a full bankable feasibility study, 43-101 compliant, that shows that we have a very large reserve to produce 100,000 ton a year flake concentrate for 25-year mine life, and we have all the economics, $1.3 billion Canadian net present value project, so our cost, so it's all made independent by engineers. We just published that 2 weeks ago, so it's a very big milestone for a junior company like us actually. And at the same time, we decided it's graphite, it's not gold, it's not a base metals where that is priced in London, So we needed to send a lot of samples to customer. We need to send a lot of product to customer before they accept to put it, to make a sale contract. So we decided to do a plant. We invested $12 million to build a first phase 1 plant to produce 2,000 tons of flake. So we started that 2 months ago. Full operation. We built it in the rest of the year, earlier this year. So now for the next 2 years, we'll be producing graphite, sell it to customer, hopefully get those sales agreement in place in time to get our project financing to build our big mine. That's how it works, and then you have all those sales, you have all those interested party, and you can raise the big capital to build the mine itself in 2020.
Interesting. So basically, unlike other commodities like gold, the customer has to make sure that the graphite meets their standards.
Exactly. And there's a lot of product you can do in graphite. As I said at the beginning, there's tons of application. So for foil, for iPhone, for expandable graphite, you prefer to use the big flakes.
Okay.
So there's a premium when the flake is bigger, when the purity is higher after flotation. And then for refractory bricks, you can use the medium flakes. For pencils or for spherical graphite for battery, you use the fine flakes. So you need to actually develop the marketing strategy around your signature that you have at your mine. And the big strength of our project is we have exactly the same signature of concentrate that our neighbor has at Lac des Îles, the mine, Imerys mine. Mm-hmm. And they are depleted. So there's a good chance that we can work at securing that part of the market, the legacy
kind of
market,
pick up where they left off, kind of.
Exactly. And the lithium-ion battery market, it's a new market. So there's Tesla, there's LG Chem in America, there's a bunch of smaller players like Exalt, like Enerdale, and yesterday we had an announcement of SKI actually from Korea.
Okay. Mm-hmm.
That they announced a 10 gigawatt plant in Georgia. So 10 gigawatt hour capacity plant per year. It's a third of Tesla, so it's a big plant anyway. So it's another 12,000 ton a year of graphite will be needed there. So there's Daimler who announced something in Alabama. So all those guys, currently they would import graphite from China with a 10% tariff.
We're knocking off the tariff, and we're also probably knocking off a lot of transportation costs too.
And also one very important thing that is cherished to me is very important. We do an all-electric mine. So our mine is fully electric. Our main partner in the project is ABB. They have a big research center in Montreal. Mm-hmm. We have another partner, Medatech, who's doing the conversion of the trucks into all-electric trucks.
Oh, wow.
So the 14% that is currently in the battery of graphite, we want it to be carbon neutral. So I hope one day the lithium or all those guys, they do the same. We use 100% hydroelectricity, very cheap in Quebec. So why not using an all-electric mine? It makes a lot of sense for us for the sustainability of our project.
That's great, because you hear all the time people say, well, electric cars, I mean, you have to put a lot of carbon to make the battery. But you're saying that basically when your mine is up and running, if you meet your targets, your portion of the battery would be carbon neutral.
Exactly. And that's very important. We made the comparison with China. So if we were doing a diesel mine, even if we're doing a diesel mine, we would reduce by 91% the carbon emission compared graphite produced in China with coal. We have an all-electric mine. We need to redo that study, but I would suspect we're 98-99% reduction compared China.
When I picture a mine, I'm not a mine expert, so I picture like a coal mine, right, with miners going deep underground and breathing in coal dust. But I noticed on your marketing material that it looked completely different. Tell me about how your mine works.
You blast the rock, you shovel it, you truck it, you haul it to their concentrator plant. So you break the rock. So it's a very easy process. It's a crushing, grinding, flotation process. So you break the rock without breaking the flakes. You want to preserve the flakes. Okay. And the graphite is hydrophobic, so it floats at surface. Oh. So it's a series of crushing, grinding, floating, and then you screen to separate in the big bag the big flakes and the other bags the smaller flakes. Oh, so it's a very easy process. And if it's not easy like that, you need to go back to exploration, find another deposit. You need to have the deposit that the flakes are pure.
And now, basically, this sounds pretty safe compared to a normal mine that I'm picturing, because there's no workers going underground. Everyone's operating just
it's an
machines.
Open pit. Yeah,
right,
exactly.
Okay. And now, how long does a mine like this, how long do you think it'll last?
So our study shows that 100,000 ton a year for 25.5 years. In reality, we have much bigger resource. We have but for the sake of financing our project and the bankers, they don't care more than 25 years.
I see. Now, I heard about your company a year or two ago, and I invested, so I'm an investor, just so everybody knows.
Oh, great.
But if somebody's watching and they would like to invest in your company, is there a way for just kind of regular people to invest in your company?
Sure. We are publicly listed, so we are on the Canadian Venture Exchange. NOU is on our symbol, NOU. And if you are in the US and you want to invest in the US dollar, it's NMGRF.
So you just, your background is you're a geologist. You have degrees in geology, geophysics. You've traveled the world doing your work. In fact, you even went to the North Pole. I was excited to hear.
Yeah, exactly. I was from 2006 to until I started the company in 2012. I was a geophysicist working with a very large airborne geophysical company, and I was fortunate to travel the world. Actually, I went in Saudi to do some airborne geophysics there, but I went also to the North Pole with the NASA. It was a very interesting project. Yeah.
And now you were also an infantry officer in the Canadian Forces, and it sounds like a lot of the skills that you taught there are very applicable in your new role now as a CEO.
Yeah, exactly. Because I must say that as a geophysicist at school, they don't train you to manage people. So sometimes it's a challenge to manage people. But that's part-time. I was doing my study during the day, and at night and during weekend I was an infantry officer. I was doing all my summers with the regular force. So it's a very good learning experience. You learn a lot on yourself when you are in the military. And
you have a very unique background, because having the science but also having the management is I would say pretty unique. Yeah,
I guess not unique, but we are what we are.
Right.
So having started this company since 2012 was also a very, very interesting experience to go. If you look, it's very rare that a company start from scratch, no asset, explore, discover, and then develop and start production, like within a very short time frame. Mm-hmm. We're very fortunate to have done that, and I've learned through that. And now we have a fantastic team. We're now 25 employees. We have all ex-Imerys experts. So Carl is our chief of operation. You need a guy like Carl. Is really the sergeant managing the people on the ground. He's a fantastic guy. He was for 6 years natural graphite operation leader for Imerys. Our CFO was actually 5 years financial controller for Imerys Graphite and Carbon. We have the sales guy from Imerys. We have our plant manager, the process manager was 25 years over there.
Wow.
So if I wouldn't have those guys who've done it and they know how to process graphite, it would be a different story. But those guys are key in the story.
Now, a big piece to this puzzle is, like you said, there's already a big market for graphite, forgetting about batteries, but now there's batteries. So in your line of work, you're looking, many years down the road, whereas most of us are just looking at what's right in front of us. So what do you see, what do you feel about EV batteries and battery technology that we might not be thinking about?
Lithium-ion started, I think it was invented in 1974 by Dr. Goodenow in Texas. Mm-hmm. Sony started the commercialization of it in the 90s. And it's only after a lot of work, a lot of incremental work on the cost, on the technologies, how to process everything to go in a battery, that today we can have what we have. A Tesla that is the most phenomenal car on the planet, and then you have all the Chinese new guys. You have Rivian, who started a very nice truck. I'm really keen to see where it goes.
I know, me too.
So it's just after all that work on the same chemistry for over 25 years that we are at the stage where we can compete with the combustion engine car. Mm-hmm. With yesterday's announcement, SKI in the US, we have 60 plants, 60 mega factories that are being built on the planet.
Wow.
And if you consider all those factories, by 2023 will require over 500,000 ton more of graphite. 2028, 1 million ton more of graphite at least. So personally, in the business I am, the question is, when we'll need less graphite? When the graphite market will start to decline. And I don't see that, even though we have another technology in the next 10, 15 years that is being developed. I think we finally have a recipe that works. We have a solution that works. It's safe enough. Everything works now, and all the other technology have something wrong that need to be fixed.
Right.
So I think we are with lithium-ion batteries for a while.
Now, where are you on the curve? So, a lot of people say, oh yeah, I think EVs will do, but it'll be 40 or 50 years before they dominate the market. Where do you think EVs will start to dominate the market?
I believe starting in 2025, like if you look at Norway, Norway, it's over 50% of cars is EV.
Yeah.
But, if you look Europe, it's not like this. US is not like this. I think in California is 4%, even though we think there's Tesla every corner. So it's not.
Right.
But now you start to see an impact. GM is shutting down plants.
Yeah.
And they are thinking of going to EV. So I would say 2025, in my mind, that's where you will start to be above 10%. It's a 4 times more heavy than the gas for the same energy, So that's I would say the weakness of lithium-ion battery.
Right. I think a lot of people, they write to us all the time and they say, how can we invest in this electric future besides just, say, Tesla or NIO? And I often say to them, those cars need parts that go into them. So look at the supply chain, and you are a huge part of that supply chain.
Yeah. So I think 2 places to invest: raw materials at the end of the chain, and car maker at the other end, that can have flexibility, more flexibility on their margins.
I think a lot of environmentalists would say to me, I have a problem, Zach, in investing in a mine because mines are destructive to the environment. And so I guess what I really liked hearing, and one of the reasons I invested in your mine, is that you are putting so much emphasis on being carbon neutral. So can we just talk for a second? When I see all these big machines, there's going to be trucks, there's going to be all these machines that are mixing the material. You're saying that basically your plan is to make them electric.
Yeah, exactly. So, but making an electric car is not green.
Right.
It's greener.
Right.
Being realistic, before we get to that point where we are all in a simulation, we need to transport ourselves. We need to fly ourselves once in a while. We need to eat. We need to. So an electric car is obviously greener, but we don't want to take the pollution that is being made currently in Asia and make it here in my homeland in Quebec, obviously. So we really need to develop those materials in the car that are green, zero, the zero emission, or the closest possible to zero emission. But, it will never be totally green. We need 10% EV next year. That's what he's asking to all the car makers. So it's the biggest car market in the world is asking for 10% EV next year. And it's not for fun. It's really be survival for them. It's totally different reasons. And
then just lastly, when people see a mine and they see an open pit, they probably feel like, it's a big, scar in the earth. But I think they don't see that probably, I'm sure, down the road, when you're done with that pit, you can just regrow what was there. So it's a 2-kilometer total mineralization that we are planning to mine first. So we start south, and then when we move, we backfill behind us. Progressive regeneration. So we are seeding trees, planting trees in the back, and then we move, and at the end, there's only the last pit that become a lake. But you're totally right. There's a lot of unknown about mining. And if you Google mine open pit, sometimes it's not the nicest thing you see, unless you are a geologist and you like to see rock. Right. Well, thank you so much for your time today. That was very illustrative. It really opened my eyes as to what's going on, because I think for a lot of us, when we hear about something like graphite, our eyes glaze over and we're like, I don't know where you use graphite, but this was really interesting. So thank you for sharing that with our viewers today. Thanks, Zach. And anytime, and any of your auditors, if they want to visit our project, we're 2 hours north of Montreal. Nice. So we can pick them up. It will be a carbon neutral visit. We'll do it in Tesla. From Montreal, super easy visit. So great. I'll be your host anytime you want to visit the project. Thank you so much. I appreciate that. Thanks so much for watching Now You Know. We work hard to bring you videos about things that we think you'll find useful, but we need to know from you what you want to see. So leave your comments below. Also, don't forget to go over to our Patreon page, where for as little as $1 a month, you can watch our Patreon bonus story every week on Tesla Time News. Thanks again. We'll see you soon.